Hey, what's up, people? My name is Alex Zablov, and I would like to show you my sound of the engine, of the car engine. So here you can hear, so listen to the sound, and I'll explain you how to make the same just in a few seconds. Maybe it's not perfect, I don't know. I just spent 2 days to figure out how to make it, and now I would like to explain it. Yeah, maybe later I'll adjust it a little bit here, a little bit there. So, alright. First of all, for that, you have to create your meta sound source file. Just do right click and search for meta sound source and create a file. Then open it up, and here you will make your own logic. Of course, you don't have everything this in front of your eyes on your PC, but let's recreate. You should recreate this toward having a similar sound. And I don't know. It's just not a tutorial for beginners. You probably have to understand how it works, because it would take too much time, but to explain everything how it works. But I'll try to explain something for beginners, and at the same time I just want to showcase you the main principle how to make this type of engine sound. So first of all, take a look right here, right now. You can just, if you know how to do that, just copy this logic and recreate it. So I'll go through it, and this logic creates exactly that sound which you heard just a few seconds ago. And also I have a custom note frequency. Here it is. It's just very simple. If you know how to do that, you just can replicate it. And then I'll explain you how to make it if you don't know, and what exactly each note means. So first of all, I can click play, and you will hear the idle sound, the idle when the car is standing and actually not running. And then I have an input throttle on. So it means that we run the car, we drive the car, and now we increase the speed. Actually, not speed, but RPM or RMP. I don't remember how it's in English. Yeah, and also I want to show you the second part of this logic. When you have a car, you can open the car blueprint. I have created a separate blueprint component for the car, but you can make this logic right in the blueprint of the car. And here on event tick, I'm sending the float parameter speed. I'm taking it from the vehicle movement component. So there is a car. Let me find it. Here it is. So there is a car. It's a Epic Games car. And here I have a vehicle movement component. Everybody has it in Epic Games car, so you can find it. And also I have added a separate vehicle blueprint component to write all logic there. So here it is, vehicle blueprint component. If you didn't know how to make your component, you just create a blueprint class, and here it is, actor component. You just create the component, and then you drop it here, and now you will have it. and then you can create our logic here. It's just very convenient because it's easy to manage, and it's very compact in comparison with making our logic in one blueprint. So okay, all right, let's get back to the business. Here is the sequence, and I have here 5 important steps. The first step, I'm getting the vehicle movement component, and yeah, by the way, to get it at the even begin play, you should get the owner and get component by class, and here you select the class, and then you promote it to a variable. So the class of that vehicle movement component. You know what I mean, right? So then you promote it, and also I casted it to vehicle the vehicle movement component, because not all functions exist in this component. Some additional exist in this component. So that's why I casted to it separately. All right, and then on the event tick, each tick I'm sending the what I'm sending. I'm sending the speed, which is from 0 to 1. It's always from 0 to 1. Why? Because I'm getting the engine rotation speed, and then I'm dividing it on the engine max rotation speed, and it returns a number from 0 to 1. And the next thing is that I'm executing trigger parameters when when I have input, when I press forward on backward with this node, it returns either 1 or 0. It means that I'm triggering it or not. I'm triggering or not triggering. And it also executes each tick. And another thing is forward speed. I'm getting a forward speed, and then I do ABS to get rid of the minus. If I have a minus in my speed, if I move backward, I have a minus. So I'm getting rid of minus with this node ABS. It's absolute, as far as I know, absolute number. And I'm sending it to the engine sound forward speed parameter. Engine sound is this file. It's meta sound source, which you just have created a few minutes ago. This is the main file with the sound. And also I have added this engine sound file to the to our vehicle. You know, this is our vehicle class, and I have added the engine sound to its components. So, and yeah, what I do next is let me figure out. So, all right, you understand, right? I'm sending different data, such as forward speed, such as has speed in general, or no speed. Actually, it's not has speed, no speed. It's yeah, it's has speed or no speed. It just triggers when it changes. So I'm saving previous speed here, and then I compare. If the current speed is not equal 0, it means that the car is running, and then I'm checking if it was running before. If it was not running before, it means that the speed has changed, the um, the state has changed, and now the car has speed. Otherwise, I'm checking if it doesn't have speed, if it stops. With this logic, only this node should be there. Alright, you just can copy paste it, and you just can deep dive to understand how it works. This is all nodes. And this is not just to get out of the vehicle. You don't need it. And the next thing that we go again to the engine sound. So as you remember, we get the speed from the vehicle blueprint component, and then it just calculates the frequency with this node based on throttle on or off, and then it goes to the elif-o node, and then it goes to the sine node, then it goes to wave shaper node, and that's the most important. These are the most important things. What is next is just tuning. So let me show. Let's get rid of these nodes just temporarily. They are not really needed, actually. It's just for beautiful sound. So without them it also works pretty good. And then let's throttle on, and then let's adjust the speed. You see, it's very simple. That's all you need. But I think that sound will be better with these additional nodes. They are filters. So this filter removes this frequency. This filter increase this frequency. This filter adjusts this part of frequency. And here I also add the sound of tires, you know, when the wheel runs on a ground. Yeah. What can I explain you else, guys? Finally, when you get out of the car, you should invoke the stop input, and you should trigger unfinished output. It's important to kill the process of this acid engine sound. Yeah, you see this trigger stop here. When I get out of the car, I probably have not added it, you know. I should do that right now. So, you know, just like that. Stop. It's called stop. Yeah, here it is. This is how we trigger some triggers. So you just pull out from your meta sound component, you just pull out execute trigger parameter, and then you enter here the name of the trigger. How you added triggers, let me explain if you don't know. You just create an input, you just call it somehow, and then in the type you select a trigger, and here it is. Now we have this awesome trigger, guys, and you can trigger it anytime with this node execute trigger parameter. And what else? You just can create any variables in the same way. For example, variables 1111111, and here you just select the type, float or boolean or something else, integer, and then you can access it in the same similar way as I did here. Set float parameter, and you will set this parameter. Just enter its name. In our case, it's 111, many ones, and you just should enter here that name. That's all, and you can access any variables like that. And also this node, maybe it can be useful for you to know. This node, it sets this value. So we have this value, and initially it's 0, and then when I trigger set, it becomes 1. When I trigger reset, it becomes 0 again, and it returns it as the output value. And then here I have a node interrupt 2. It's especially to make interpolation for the change. So it doesn't change instantly anymore. It will change smoothly with an interpolation. And here you enter the time for the interpolation, how long the smoothness will go. So yeah, these nodes are pretty important and useful. Everything other are inputs, and then these nodes are the main characters of this logic. I hope you understand what I mean. I mean, these nodes are the main things. So the first one is sine. It generates a sine. So when I press, you see here we have a wave, and in our case it's not a sine already, because I also have LFO before the sine, and I also have the wave sharper. So what wave sharper does, let me show. So it changes the wave actually a little bit, and it changes the sound as well. And LFO is probably difficult to explain. It's something like it makes the second layer over the sine. It has its own frequency. It has mean and max value, and it just changes the output from mean value to max value with this frequency. In our case, you see, the value changes from 10 to 20 with the frequency, with this frequency. It means that the frequency of the sines will be also dynamic, and it just make a special sound similar to engine sound. So yeah, these three nodes are the main ones. Just believe me. Everything other is just logic to turn it on and off, and just tune it a little bit, make it faster or slower, but these notes are the main ones. These notes make it a little bit better for your ears, and this note add the sound of the ground. So it just a regular player. You just pull it out from here, and you can add any type of sound players to your blueprint, and then you select the sound. In my case, I'm sorry, you're probably tired of the sound. So in my case, it's tires. Here it is. And here it is. And yeah, I played when I has speed. I start to play it. When I has no speed, I stop it. And also I adjust pitch. Pitch is related to speed, to the forward speed, which we get from here. You see, I get forward speed and then I send it to the parameter. And then I mix it. There is a mixer. You can choose many different quantities of inputs. In my case, it's just 2 inputs. The first input is the sound of the engine, and the second input is the sound of tires, of wheels. And gain is mainly like the volume of the sound. And yeah, then it mix and send it to the output. Yeah, that's it. Let's drive it one more time. It's idle. Maybe I should do something with the sound of tires. I don't really like it them. So let's disable them temporarily. And you will hear the sound of the engine without. Yeah, probably it's better. I even don't know, frankly. I just want to add the sound of tires because it's gonna be more realistic. But at the same time, I don't know. I should produce my own sound for tires. It's difficult to find it on the internet, you know. Yeah, that's it, guys. I hope you liked the video. Click the like if you liked, please. It will support my labor. And also take a look at the game I have been developing for many years already. And have a nice day.